status. Okay, so let's see that.
All right, so one thing is if you check the git log to look at the last commit, we can see
Working again.
Yeah, so if you do something like git show head, we'll see the details on that.
Oh, okay.
We can just say head, yeah, or that would be the commit before head. Yeah, that's right. So you see this co-authored by. Have you seen this before? This is a GitHub feature.
That's actually okay. I need to have a look. I use Git so many years, but actually,
yeah. Well, I discovered this recently, and it's really nice for things like this because it will show up on GitHub as both of us. You know.
Oh, I didn't know about this.
Yeah, so it's not a Git thing as such, but GitHub reads this special magic text from the commit message, so we can do the same.
So how it would work?
So you can commit this under your name if you like. So add what we've done. We'll do the commit message. What did we do? We added display result, didn't we? And I digressed a lot.
Or?
No, I think that's fine. And I digressed a lot about 8-bit computer games, but I didn't have any tangible effect on the Git repo, so we can ignore that. And in fact, well, suppose if you just do git commit with no -m, then it should open your editor to ask for the message, and then we can do the co-authored by. So delete that string too, so that we just say git commit on its own.
Okay, that's true.
And then it'll say, well, you need to provide a message.
Yes. Oh.
You can make your default editor code if you like. I do.
Okay, now I have set up for Vim. Yeah. So basically, when you are committing, automatically VS Code, it starts. Okay.
Yep.
Well,
I love Vim too. Don't get me wrong.
Display the results. Okay, so this is our commit message.
Yeah, but I
and
used.
What, and you?
Yeah, we're saying co-authored by. That's right, colon, and then me, which is john@bitfieldconsulting.com. So yeah, I think that's great.
Okay, are we taking one space or not?
I don't think that matters.
Okay. Other display results. Okay, so here we go. This will be ignored. Here we go.
Great. Okay. Are we ready for the next thing?
Yeah.
Okay. So are we done with main yet? I don't think we are we?
Let's have a look here. Yeah.
We still have stuff in main, so we don't like this. We want to get rid of that. And so ideally, we would like to say something like just lambda.runGame, isn't it? And we could do that since there's absolutely no configuration whatsoever. You know, and even if there were, we could pass it to runGame. So suppose we imagined what would that runGame method look like, or what would we test about it, let's say. If you call runGame from a test, that's a demanding test, isn't it?
Yeah, it's too much, I would say. Yeah.
Well, you actually have to play the game to a certain extent, and this is possible because you could say, you know, suppose you had some input reader which would really be standard in, but we can fake it. So you could pass that to the game, and you could put some user input in there, couldn't you? You could put in, 110 or something. So you could say, if you call run game, what would it do? It would create a new game, and it would run this loop. The first thing it would do would be display its state to a fake buffer. Then it would try to read the thrust setting from its input. That would be there, because we faked it in beforehand. Next game tick, well, that's the end, isn't it? And it should display a success message. So we actually know, we know the exact details of every tick of the game and the final state. So we're like Laplace's demon for this simulation. So we can actually do that, can't we?
Yeah.
So what we need is just an input buffer and an output buffer, and we have a test like that already. So we could probably start by stealing that.
Yeah. Put where we have buffers first. Okay, display state. Okay, so we have here.
Yeah, test read thrust is the only one where we fake both the input and the output, I think.
Thrust. Okay, so let's copy.
Yeah, I've put a to-do in code there, which hasn't been done, which is what happens with all to-dos in code, isn't it? That's why we don't do that.
Oh, play game, something like this?
Yeah,
or you have to...
play game sounds good.
Oh. This stays the same at this moment.
Yeah, new game is all fine. And then the logic of what we're saying is that there should be some G dot. Well, actually, we don't even want to have to create a G in main, do we? We want to just go play game. I don't care that there's a game state object. I'm not interested in it. I don't need to look at it. So I won't. So we're actually going to call run game directly.
So basically, this won't be here.
Yeah, so I like to start from the middle out when I'm not sure what to do. So I know in the middle of my test is always going to be calling the function, and I'm probably going to have to do some setup and create some inputs and then check the outputs and so forth, but that's the middle, so I can do that.
Okay, so let's comment out this before deleting, and we need to basically have what? Play game, right?
Yeah, we're saying it'll be lambda.playgame because it'll just be a global function that you can call.
And this function basically.
Yeah.
So we have lander game, play game. Okay.
Now we have a slight problem here in that where are we going to inject our fakes? Because we need to do that, don't we?
Yeah, that's a good question.
So we could say, what usually when you usually have some configuration to pass in, don't you? But if there's a sensible default, we would like to not force the user to supply it. We can take a reader and a writer here, but we don't want to have to force the user to pass OS standard in and standard out. That's just dumb. That's obviously what they want. So how can we make optional parameters to a function? I think you know.
Functional options, right?
Yeah, exactly. It's funny how everything always seems to come around to functional options, but we definitely know how to do that, because what we're envisioning is we're saying we'd like to be able to just call play game with no parameters, and main will do that. But secretly, behind the scenes, play game actually takes parameters. What does it take? It takes a variadic number of options.
Yeah.
What would those options be? Well, your input and output writers would be options, wouldn't they? So you could say something like lambda.playGame. In the test, you can say lambda.playGame with input, fake buffer, with output, other fake buffer. So suppose we write that, again, assuming that we're on top of the Zen Mountain, and then we'll just figure out what to do to make that work.
So this will be basically our function passed to play game, right?
Yeah, and we usually write this multi-line. So we would do a new line here, and then we would say, some option. How do we create that option? Well, there'll be some function we call which creates it for us. So we would call lambda.with input, let's say.
Something like
lambda.with input. Yeah, because it's a function in the lambda package which is going to give us the option. Great. We can construct our input reader, can't we? Let's just assume we have, and it's called input. And we'll pass that.
And this will be some IO reader, right?
Yeah, we called it input before, didn't we? So let's stay with that.
Okay.
And then we're going to pass another option.
Input.
Yep, so on another line we can say lambda.with output, because you probably end up with a bunch of these, don't you? And having each one on its own line is more readable. That seems logical. Great. And the neat thing about this is, like, you could say, if this is all it is, doesn't seem that great. But the really neat thing is that you don't have to supply these, isn't it? You can just call lambda.playGame with no arguments, and it will assume you want standard in and standard out, which would make sense. Great. So, okay. So, continuing our mountaintop adventure, we can construct our input and output, which I think we already have that commented out, don't we? We've got that below.
Yeah.
So we need those before this call. Yeah, these can move up. Wonderful. That makes the compiler happier. And so, okay, so what's our want?
So
this is a bit tricky, isn't it? I love to tell people that all they have to do is compare want and got in the test, but then sometimes working out what your want is can actually be non-trivial, can't it?
So we need to output depends on the functional options we put over there, right?
Yeah, well, when this function call returns, that's the end of the game. The game will be over. So what could we look at? We could look at the output buffer to see what message was printed, couldn't we? In fact, we know the entire output of the game, because we know the input. And in fact, we don't need to worry about what it actually is, because the game will tell us immediately that we run this test successfully. Or, it'll fail, and it'll say, wanted empty string, but got all of this output. And then we just make that our expectation, because we're in the privileged position of knowing it actually works right now, aren't we? That always makes tests easier. It's when you already have working code. This is effectively just a refactoring test. So, what does that mean? Well, we can call output.string, can't we? And we can say, is it exactly the following string, empty string? Suppose we make that our got, and let's just say want is empty string for now.
Yeah, we know what we. So got is what we want now.
Yeah, we don't know exactly. We do know, but
Yeah.
we just can't be bothered to type it. So we'll let the game print it out for us in the test failure, and then we'll just copy it.
Mhm.
This is a nice time saver. So let's just want empty string for now. It definitely won't be that.
Let's leave it like this.
Great. And the rest is trivial. Actually, we're comparing floats here, whereas we'd like to compare strings. This feels like a comp.equal, doesn't it?
Oh yeah. That is correct.
Yeah. We can just copy and paste it, can't we? Because it's trivial. And by the way, I think people sometimes misunderstand what we mean by saying trivial about programming, don't they? I have seen people who misinterpreted this to mean when someone tells them such and such is trivial, they heard it as meaning, you must be an idiot if you don't understand this sort of thing. Like, that's definitely not what we mean, is it? We mean something more like this is something which we may not know exactly what to do, but we know that when we come to do it, it won't really be that hard. We'll just be able to sort of bash it out. Still thinking required, but not serious brain busting, Like if I said to you, write a program to generate prime numbers or the Fibonacci sequence, you could think of that as trivial, not because you know exactly what the program would be, you might do, but you need
Yeah.
but you just know that you could do it, right? Not too big of a job. If for whatever reason you didn't know some requisite facts or algorithm or something, you just look those up. Real life is an open book test. You can use Google, so that's all right. When we say trivial, we mean trivial with access to Google and Stack Overflow.
Exactly. Or a few books, for example.
Right. So this looks great. In fact, I think it's just t.error, isn't it, here? We have error f. Yep, that's perfect. Now, we don't have some of this machinery yet, but that's okay. We can... So we don't need new game anymore. We don't need the G, and there's no error. That can all go. So just to recap, what we're doing here is we're saying, suppose we created a fake user, who just types the number 10 and hits new line when prompted. That's what our input buffer is. And we construct a fake output terminal, which doesn't actually print anything, but we can look at it to see what was printed. And then we say, hey Lambda, play the game with the fake input user, fake output buffer. Run the game through that loop until it's completed, and then I will look at what you wrote to the output and say, is it exactly this? We know what it'll be, don't we? It'll be the welcome to the game message, first state vector, typing in line 10, another state vector, and in fact they've only got one turn, so at that point that'll be the end. And it should... What? Will they succeed or fail, do you think, in this simulated game?
Right now we don't have implemented this, so of course it will.
Right, but when that is working, when you played the game and you typed in 10, I think you crashed, didn't you?
Yes.
So the same thing should happen here. Physics is deterministic, at least if you don't take quantum effects into account. So it should be the same. So we should see a crash message. We'll see what we actually get, but we need to build a little bit of this machinery, don't we?
Yeah.
But it's pretty trivial, so suppose we start with a play game method. I said trivial again. It's very much non-trivial, but we'll try and make it trivial.